is about identifying redox reactions and reducing and oxidizing agents. So at this point you should know how to determine the oxidation numbers, and the purpose of really determining oxidation numbers is actually now when we get into the reactions, can we see where the electrons are transferred? Can we calculate the number of electrons that's been moved from one species to another? That's really the purpose of your oxidation numbers. So here's an example, and what redox reaction is, one really good way of remembering is that you're looking, basically what you're remembering is which one is gaining electrons, which one is losing electrons. And one really good way is the line goes GER. What that means that if something loses electrons, if loses electrons, then it is oxidized, and if it gains electrons, that is reduced. So that's looking at that individual atom or element. So here's an example. So once you have like a big reaction, then you have to determine, well, is this a redox reaction, and if so, then which one gained or lost electrons? So let's see. First, you have to identify all the oxidation numbers. So in this example, you might want to pause it and see if you can identify the oxidation numbers. So let's start. This is -2 and then -4 for oxygen, and which balances out to 5 plus 4 plus 4. HCl -1 plus -1 plus 1 plus 1. -1 for chlorine. I have 2 of them, so -2, which balances it out to, why do I keep saying 5? Plus 2 and plus 2. Chlorine is by itself in a diatomic molecule, so this is just a 0, and water is -2 plus 2 plus 1. It's usually not water. So now I have to go and see the different elements and see if the electrons have been transferred. So this one, manganese, has a +4, and after the reaction it actually has a +2. So actually it has gained some negatives because it gained 2 electrons, because it gained 2 negative charges to make this decrease in number. So because it gained electrons, this one is reduced. And then let's look for another one. Oxygen is -2 here, -2, so that's okay. Hydrogen is usually okay, +1 plus 1, so it has to be chlorine, and you can see that it went from a -1 to 0. That means it actually became more positive. So this one actually lost 1 electron. So this is actually your oxidized one. So if we were to break this down, what was oxidized? Well, chlorine was oxidized, as we can see here. What was reduced? That is your manganese was reduced. Now then we look at something what we call an oxidizing agent. Oxidizing agent and reducing agent. This is sort of like the opposite of what's actually happening, as in that if we identify the oxidizing agent, this is the compound that's causing the other to lose electrons. So what it is basically, if you have your reduced one, then that is your oxidizing agent, because manganese caused chlorine to lose electrons. That's why it's called the agent. And for reducing agent is basically connects with the opposite, which is your oxidized, and that's your Cl. So this is the one that caused manganese to gain the electrons. And for oxidizing agent and reducing agent, it's actually not just the element but the actual compound, because you put in the whole compound into your solution. So an oxidizing agent in this sense is actually MnO2. That's your oxidizing agent. That's what you put in to cause the other to lose electrons. And the reducing agent here is your hydrochloric acid. This is the one that caused your manganese to gain electrons. So it gave the electrons to the manganese. Okay, so that's how you determine it. Here are 2 other examples, and if you want to just pause it and try to identify these as well. So first off, identify the oxidation numbers. Iron is standalone solid, so it's 0. Chlorine diatomic molecule, so that's a 0 as well. Now we look at this compound. So chlorine has a -1, have 3 of them, -3. Balance this out to be +3. +3 for each iron. So you can see from going from 0 to +3, you have lost 3 electrons. So that's going to be your oxidized. and then if that's going to be oxidized, then this one must be your reduced, and it is because it gained 1 electron, and that's your reduced. So if we were to write all this stuff down, oxidized is your iron, and your reduced is your chlorine. And if you're looking at the oxidizing agent, then this is basically your reduced one, and this is not the element but the entire thing. So this is going to be your Cl2, and then your reducing agent, the one that caused the other to gain the electron, is your iron solid. Okay, so that's how you identify that, and it is a redox reaction. The next example, let's try this one. So oxygen is -2, +2, +2. This is 0, -2, +1 for water. Doesn't really change that much. For iron hydroxide, you can see that we can split this. So this is going to be hydroxide has a -1 charge, but because I have 3 of them, so on the right side has the overall charge of -3, which makes iron a +3. That's how I want to figure that out. And then oxygen is going to be my -2 and then +1. So now let's identify which one is your oxidized one or reduced one. So let's look at iron. That's a metal. I know it's going to do something. So it went from a +2 to a +3. So it actually has lost 1 electron. So this is going to be your oxidized one. And then if we were to look at it, this other ones, you can see that this oxygen actually didn't change, but this O2, the oxygen by itself, actually gained -2. So it has gained 2 electrons to get into your hydroxide. And this is your reduced one. So then we can break this down as well. So oxidized is my iron, and then my reduced one is my O2, and oxidizing agent is my reduced one. So this is going to be my O2, and then my reducing agent is my FeO. So that's how you identify if a reaction is redox. Which one is oxidized, reduced, oxidizing agents, and reducing agents, and that's pretty much it. And you know that you need to know how to identify the oxidation numbers before you do this. So try some practice questions, and I'm sure you'll get it. So see you later.